All right, guys. So in this video, we're going to be talking about how to create a confidence interval for a difference of two means. So a reminder with how to do that. All confidence intervals are calculated the same way. You take your statistic plus and minus your critical value multiplied by the standard deviation of the statistic. And so for us in this context, our statistic being a difference of means is going to be x bar 1 minus x bar 2. Plus and minus our critical value is going to be t star, multiplied by, in this case, our standard error of the statistic, because remember, if we're trying to estimate a difference, we're not going to know the population standard deviations, so we have to call it standard error, but it is the square root of s sub 1 squared over n1 plus s sub 2 squared over n2. So for our context today, we're going to look at Ashlyn and Olivia, who wanted to know if generic chocolate chip cookies have as many chocolate chips as the name brand. So to investigate this, they randomly selected 10 bags of the name brand Chips Ahoy cookies and then 10 bags of the Walmart brand Great Value cookies, and then randomly selected one cookie from each bag. They carefully broke apart each cookie and counted the number of chocolate chips in each. So we can see the results in this table below for Chips Ahoy and Great Value. So in part A, it asks us to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. So let's go through it. First of all, let's say our parameters of interest. We're going to say mu1 is going to be the mean number of chocolate chips in the Chips Ahoy. And let's let mu2 be the mean number of your chocolate chips in the Great Value brand. And then for our confidence level, it does tell us it wants us to use a 99% confidence level. So confidence level is going to be 0.99. Next, for step 2, let's go ahead and say what procedure we're going to be doing. That's going to be a 2-sample t-interval for the difference of means. And then let's check our conditions. The first one is whether or not this data comes from a random sample or experiment. And if you look at the data, it does say that they randomly selected 10 bags. So yes, we can say that this is random. In fact, not only did they randomly select the 10 bags, they also randomly selected one cookie from each bag. So definitely plenty of randomness here. Next, let's go ahead and check our 10% condition so we can calculate standard deviation. We're going to take 10 multiplied by our sample size of 10 cookies in total is going to be 100. Could they have sampled more than 100 cookies for the, we'll say Chips Ahoy first as N1? And the answer to that is yes. Could they have also sampled more than 100 of the Great Value brand? And the answer there is also yes. So next, let's check to see for this to be approximately normal. It does not say anywhere in the problem that it's approximately normal, and unfortunately for both cases, 10 is not greater than or equal to 30. So we need to look at our data and see if there is any skew or outliers, and then we can probably proceed with caution if that's the case. So in your stat menu, make sure that you have put in your data. I've already got the data in here, so if you need to maybe pause the video and go ahead and get your data in, and then let's take a look at it. So I'm going to get rid of everything else. Let's go to our stat plot menu. I'm going to check them one at a time. So I'm going to turn plot number 1 on. I'm going to make that a histogram for list 1, and then zoom 9 for zoom stat when you're ready to graph it. And so there is going to be some moderate right skew here. I don't see any outliers, and it's not like it's majorly skewed one way or another. Not the best data for sure, but we'll go ahead and proceed with caution for that first data set. Next, let's check for list 2. We'll go ahead and change this to be list 2 now. We'll go ahead and graph it as well. And kind of the same here. Again, we're working with a limited amount of data. Looks almost uniform except for that very far right end. And so once again, I would say not any major skew. Pretty clearly there's no outliers, but definitely where we're going to have to be very cautious with our results and applying those because of the fact that there's maybe a little bit of skew. So we're going to go ahead and say proceed with caution and continue with our calculations. So for our calculations, we're going to let the calculator do our work for us today. We're going to go into the stat menu, over to tests, and we're going to scroll down until we find the 2 sample t interval, which for me is option 0. In there, we're going to make sure that data is selected because we are working with the raw data rather than the summary statistics. For list 1, we'll keep that as list 1, and list 2, we aren't using frequency lists, so keep those 1. Make sure confidence level we change to 0.99, and again for pooled we'll put no. Here in just a little bit, in fact, we'll talk about when we use pooled data versus when we don't. So again, for right now, just leave that as no. And then when we calculate this, here's going to be our confidence interval. It looks like our confidence interval is going to be from negative 4.814 up to 2.8138. And then notice that it gives you a whole lot of information here about the 2 data sets. The one thing it does not tell us is our t-star value, which is the other thing that you need to state when you're doing your do step. So to find our t-star value, this is where we're going to have to use inverse t in order to find it. Remember, for inverse t, we have to use area to the left. So a 99% confidence interval leaves 1% for the tails. For each tail, that means 0.005. And so inverse t being area to the left, I'll have to use 0.005. And then remember, for degrees of freedom, that is 1 less than our sample size. So for degrees of freedom, we'd be taking 10 minus 1 is 9. And also for our second degree of freedom, 10 minus 1 is 9. The lesser of those 2 would still be 9. So that would be our degrees of freedom here. So using our distributions menu, let's go ahead and use inverse t to find that. So 0.005 for my area, degrees of freedom being 9. And then when I paste that in, I'll find that my critical value t star was equal to about plus or minus 3.25, I guess, if you were to go to 2 decimal places. So last but not least, let's go ahead and interpret our confidence interval in context. So we can say that we are 99% confident that the interval from negative 4.814 to 2.8138 captures the true difference in proportions, or difference in means of the number of chocolate chips. And then make sure we say what direction we did that. That was taking the Chips Ahoy brand minus the Great Value brand. So does our interval from that provide convincing evidence that there is a difference in the number of chocolate chips? Remember, what this is asking is there the possibility that there is no difference? In other words, is 0 contained within our interval? And the answer is 0 is contained within our interval. So does this provide convincing evidence? We would say no, there is not evidence of a difference. So again, not evidence of a difference. What that means is, again, 0 is in our interval. There's still the possibility that there is no difference. In fact, it looks like they're pretty darn close to each other in terms of how many chocolate chips are in each. So last but not least, let's talk about pooled data. When do we use pooled data versus when do we not? So when we're pooling data, the difference will definitely be whether or not we're doing a z-test versus a t-test. For a z-test, we will always use pooled data. So pooled data is always used for both proportions and means in a z-test. Now remember, for means, the standard deviation has to be known in order for us to obviously do a t-test or a z-test for a mean. Whereas for t procedures, pooled data is not very often used. So in order for pooled data to be used, population variances must be equal to each other, and also population distributions have to be exactly normal. Now notice I've underlined that word exactly. They cannot just be approximately normal. They have to be exactly normal in order to use pooled data. So why do we use pooled data? Well, pooled data is oftentimes used because it leads to smaller confidence intervals. And so you can have a smaller confidence interval, which still captures your true population parameter. So pooled data is the preferred option when we can use it. The unfortunate part is, especially for T procedures, we can almost never use our T procedures with pooled data because of those two conditions that have to be met. All right, guys, that is it for confidence intervals for a difference of means. Until next time, have a good day.